Hello, welcome and an excellent evening. I have here a new project, the One ROM replacement. This is by Piers Finlayson, also known as Piers Rocks. I will link to his YouTube channel down below, I think. And he was initially repairing some Commodore machines, floppy drives, and some other stuff. But I think he required a ROM replacement because one of the little ROM chips in one of the machines was dead or something, or he wanted to debug something. And then he started to design these things here. This being the One ROM ICE, because it's blue, running on an ST32F microcontroller, replacing arbitrary 28-pin ROMs, so to speak, also EPROMs. For example, something like this. This is the kernel ROM out of this C64 that you see in the background, and let us try and focus on this. This is better. This is a 901227-03 kernel ROM, and I do have one ROM already installed in here. We will have a look at that in a minute. And this is the other version of the One ROM. It is the Fire version, which should be red, but I forgot to click on the red solder stop or solder mask when ordering these. And this is an open source project, so you can make your own or get them from peers. There's the website for the project in the background. It is based on a sub $2 microcontroller, and all of its software and hardware is completely open source. Boards can be fabbed for under $10 each in small quantities or under $5 each in larger quantities. I think with shipping and customs, I paid around €7 per piece. So this seems to be about right. These I got from Piers himself, so I have two of those ICE versions, and you can see there's a difference because this is an older revision here. I didn't fab the very latest one. This uses a Raspberry Pi Pico debug probe, which is basically just a Pi Pico with some jumper wires to provide power and a debug interface over the GPIO pins, and this way you can flash it. But the newer revisions, as well as the ICE versions, do have USB, micro USB or USB-C, so you can directly connect it to your PC, Mac, Linux machine, whatever you like, and flash them this way. And as you can see, these replacements also have a bunch of jumpers, most notably these two here and these 5 over here. The 2 here are for additional 2 chip select lines, because you can basically plop in one of these ROMs into this socket and replace the character ROM and the basic kernel, also the basic ROM, also on a C64 by tapping into the 2 chip selects for these. And you just run a jumper wire to these extra pins, which I won't be doing. I already desoldered this very perfectly fine chip from this assembly 250425, just so I can show it off to you. So yeah, I didn't break anything here, and it would be reversible if I wanted to. So I'll probably plug the original ROM back in here after I finish my demonstration here. That being said, you can download everything from the OneROM repository, which is here on github.com psfinlayson/one-rom. And there is a quick start guide. It tells you which versions of ROMs it can replace. It can also replace 28-pin ROMs, but for that you need a different board that I don't have here. I only have those 2 variants. The 28-pin version, I think is also now ready to replace the C64 PLA, which is just out of shot here. And there's extensive documentation. The documentation is really, really great. So make sure to read that. And one thing that I needed was the Raspberry Pi Pico as a programmer, because when you receive these from the fab, they are not flashed with anything, obviously, and you need to connect them if you're using this version with the debug probe. If you're not using the version with the debug probe, you just connect it via USB to your laptop, desktop, whatever, running almost any operating system. You can even flash them from the browser, but this thing also comes with One ROM Studio, which is a desktop application basically for Windows, Mac OS, and Linux. You can download it and actually use it. And that's what I'm going to show next. Okay, so here is One ROM Studio, and it already detected the Pi Pico debug probe. We will also see how it works with the ICE USB interface. The Pi Pico probe will be identified as a CMSIS DAP, which is the standard that the debug probe adheres to. We can hit the analyze and then run detect device, and it will first try to detect an ICE board, but that will fail. And then it detects that we have firmware version 0.5.10, which is the latest one, released, I think, today or a couple of days ago. It's a Fire model, which is correct. That's what we're having here. And I only ran those 4 jumper wires for power, ground, I/O, and clock to the respective pins as described in the documentation. And it detected that it's a Fire 24-pin revision A board. The next revision will have the USB interface, so you don't need the debug probe anymore. But this here is perfectly fine, so you can still use these if you don't want to spend the money for a couple of cents for the USB port, for example. You can just use the debug probe version, so to speak. And it detected that it is running an RP2350. It also found the configuration for this. It has 2 megabytes of storage, it seems, running at 150 megahertz, no overclocking currently, and the different ROM images that are in here, like the C64 kernel, basic kernel, ROM, and C64 diagnostics, and the DES test max, which is actually very nice. I will demonstrate that in a second. Basically, you can also use this for diagnostics. If you have a halfway running system, a C64, for example, but also many other things. I do have the IEEE drives here that you can debug with those. You can put it into a VIC-20 and emulate those ROMs, and many more machines, obviously. A 1541, maybe we can dig out a 1541 and try to use that as well. That's what it detected anyway. You can also create new ROM config or use one of the existing ones, for example, for CPM 2040, 1541, 4040. That's what I actually used for debugging my broken 4040. And let's do this for the 1541 actually. The configuration is 1860 bytes. We can run build image, and image was built. It has 4 ROMs in there, 1541 ROM, different versions, -06AA, -05, and then a completely different ROM version, 1541 1540 at hex C000. I guess that might be the high and the low ROM. I'm not sure if there is such a thing. And then also a 1540 ROM version. I think the high ROMs might be the DOS, and the DOS is different. I don't know. Never looked it up, but definitely very nice that you can do that. So there are 4 different images, and I'll get to how you can select the different images in a minute as well. So we say flash the firmware, then the red light here goes on the device that is being flashed, and it will take like 10, 20, 30 seconds, something like that. And firmware was flashed successfully. We can again go to analyze and detect the device. And yeah, that did work obviously. And it says, yeah, we have the 1541 images on here. Excellent. Now let's see if we can also use the ICE device. So I'm going to unplug this contraption here, and that's my hint for you to use a breadboard to have these a little more stably attached. Be careful that you're not shorting any pins, because the rows are obviously connected together, so you have to align them in this fashion. Otherwise, you short out your precious devices. So I'm going to attach the ICE version instead of the Fire, and there's already red light because it does already contain firmware, and we can do a rescan, and it detected a USB device, an ICE USB, and we can run detect device, and there you go. That was very quick, and it detected C64 kernel, basic, character ROM, diag, and that's it. We can again flash this with something different. Let's say we also put in the 1541, so we can maybe use that in the 1541. And the flashing is basically the same, but this time we didn't need any debug probe or anything. I'm not sure if for Windows you require to install a driver or something for the USB serial. For macOS, it's definitely not needed. And for Linux, I would be very, very suspicious if you were to install anything on Linux. It usually just automatically detects this stuff and it works just fine. But please correct me if that is not the case. So firmware was flashed successfully. The one that I have in the C64 is already flashed with different things. And let's have a look at that, and then I'll also explain the different jumper settings. Okay, we have the setup running. You are currently seeing a blue screen because the machine is turned off. The One ROM Fire is inserted into the kernel socket, and there's a jumper here, but it's basically off. So if I leave the jumper off, it should, in theory, select the very first image, which is the kernel. So when I turn this on, it should be running. The red light means it's serving data. And there you go. We have a regular Commodore 64 BASIC with blinking cursor and everything. So the machine is obviously working. But imagine it were working incorrectly, because there might be some RAM error or something. You would see less BASIC bytes free than you expected. You might take one of these DeskTest Max cartridges, which we can do. We can insert this and restart the machine, and it should be starting just as expected. There is now a lot of testing happening. The RAM is being tested. The color RAM, I think, will be tested in a second, and video RAM, something like that, yes. And it will pass, because this machine is working. It did have a broken RAM chip here on U23, but that got replaced with a working one, so everything is fine. But let's say you already had the kernel ROM socketed because maybe it was broken and you determined, okay, that was broken. You put in the One ROM and you wanted to do some more diagnostics because the machine is almost running. Then you can either use one of the cartridges or put the One ROM in, and we remember that we have five images on the One ROM, and the last one on that configuration was the DeskTest Max. So basically the top row of, let me show it a bit closer, the top row of jumpers here are basically binary encoding of which image you can choose. So you can choose between 32 different images. That's the maximum that you can put on here. The rightmost one is bit number 0, then 1, 2, 3, and 4. So setting nothing chooses the 0th ROM image, which is the kernel. And 1 and 2 were, I think, basic and character ROM. 3 was the diagnostics, and 4, which would be the middle jumper. And we're gonna put this on here, but on the fire, obviously. Should be the desk test max. So there is nothing. The cartridge is not inserted anymore, and you can see here is nothing inserted. I'm gonna turn this on, and look at that. The desk test max is running without the cartridge being needed. And it will also succeed, obviously. We can also put in the diag ROM with the diag harness if we want it. I'm not gonna fetch that right now. But if you have a couple of more jumpers, sorry for the noise. Here's a couple of jumpers. We can also pick a different image, and I'm gonna turn this off for now, and I'm gonna plug in 2 jumpers on position 0 and 1. This will select the 3rd image, or 4th actually, but we're starting our count at number 0, obviously. Okay, turning it on, and this should give us the regular Commodore diagnostics, hopefully. There we go. Dead test, actually. Okay, that's the dead test, that's not the diagnostics, but the dead test is also good. Afterwards, you would still need a diagnostics cartridge with the diag harness. But I think there's probably nothing standing in the way of using the diag ROM on there as well, except that it will say that the kernel fails because it's in place of the kernel, I guess. But yeah, you can run the dead test. We won't have sound, so we can't hear the sit test, but this should run to completion as well. So that's pretty neat. So why would you choose this over a regular EPROM? Well, EPROMs are not being made anymore. I do have here, for example, this IEEE 488 interface for the C64 for Commodore PET disk drives, and it's using a EPROM, and this is from, I don't know, probably 30 years ago or something. They do last quite a long time, and you can still buy them, but they also cost a couple of bucks, and you have to make sure that they still work. You need UV light for raising those. Reprogramming takes a while. You need like a TL866 or similar device, which I have, but this here is actually much easier and much more versatile. And especially in new builds, if you want to build your C64 from scratch, you can do that nowadays. This might be a very good alternative, and there you could also do away with the jumpers and just build little solder bridges to select the ROMs that you want to use, and or use the extra chip select lines to just put in 1 chip instead of 3 different chips. Okay, so that is the C64. And just to show that we can also take this out, let me pop this out very quickly and plug in the old kernel ROM to show what the machine looks like running that, to show that this was actually always a good machine and we didn't actually require this to be replaced with One ROM, but we can, and that's very, very useful. So let's try to turn it on. I hope it doesn't break down, because I just desoldered this and I hope I didn't break anything. And there you go. Kernel works, so this board will be back to its original form. It does have an ARM SID because the SID on here was dead. It was a little unhappy board when I got it, and now it's working just fine. So these are the Fire and Ice versions. and the debug probe that you can build yourself from another Pico. You don't even need the Pico 2. The Pico 1 is totally sufficient, and that costs something like $2, $3, $4. So that's perfectly fine. But now I think we should put in this thing into a 1541 and take a look how that functions. Okay, a little bit of change of setup. The camera is now a little bit in the picture, but that doesn't matter. We still have the C64 over here. I temporarily attached the keyboard so that we can use it. This is a 1541 that has a broken read-write head, so it won't be able to read disks at the moment. Everything is connected though, especially the cables for the spindle motor and everything. It does boot up. There's no continuous head spinning. The power light is not currently on, not sure why that is, because I turned it off. So now it's turned on. You probably saw that turning for a while down here. It is visible, it's slightly visible, and you can probably hear the spinning sound, I hope. It is running off of a different ROM, because the ROM here was actually bad, as well as the read-write head. So there's an EPROM on here with an adapter. We do have the other ROM in here, which is still functioning perfectly fine. But this is exactly the situation where you might want to use the One ROM instead. So we will have to look up which jumper to set, because this is the 901229-05. We can look that up in a second. We can test that the drive is trying to work by trying to load the directory. The head is moving and then giving up with a final found. If I were to put in a diskette, it would be the same because the read head is broken. The usual stuff with the Mitsumi drive, sadly. But it's still a good test candidate for this here. So I'm turning it off. I'm turning off the C64 just to be safe. And let's attach the Fire once more to the computer, just to check what we have here. I do a rescan, and I, of course, made a mistake because I flashed this with the Fire firmware and that doesn't work. Instead, we need to pick, for this revision at least, ICE24 USB-H, and the MCU that's on here is a F411RE, which I can hardly read, but the phone here helps me decipher that. Yeah, there you can perhaps make it out just so. So let us recreate the firmware image and flash the firmware, because otherwise the floppy will not work. I can try it. It's just continually running without anything inserted here. By the way, this is the ROM adapter here, the EPROM adapter. And firmware was flashed successfully. So there you go. We will insert it now and probably should disable that window. Pin 1 is marked here and pin 1 is also over here. Drive is turned off, that's all safe. And it barely fits. It's a very snug fit with the ceramic capacitor over there. And I already picked image number 1 with the jumper here, because that should be exactly what we need. And it boots perfectly fine. So let's turn on the C64 and we get the image here, and let's again try to load a directory. It moved, it gave up, everything's working fine, and the motor stops. So that's exactly what it should be like. And to be honest, this is a much nicer looking solution, I would say, than this huge stack of things. So you can also make this whole thing much smaller if you leave out the jumpers, if you know which image you require, or images, so to speak. But especially for debugging and development and troubleshooting, this is definitely a nice thing because you're working on the open machine, etc. So yeah, there you have it. That's at least 2 machines that you can replace this with. And just for fun, we should perhaps also attach the next chip select line to pick maybe this image as well. Maybe we can replace this ROM because it's socketed, so we can just pull it out and replace it as well. Let's find out. So to achieve this, we removed the eyes again from the 1541, and in One ROM Studio I chose set 1541. With this we get multiple sets of ROMs. The set number 0 is a version with the 06AA, but we had the set number 1 basically with the 325302, which I removed. You can't see that, but here it is. That was the other ROM chip. And the 901229-05. So we still have the jumper set correctly. We can build the image, so to speak. There we go. And then we will flash the firmware. And now we should be able to run a jumper wire from the probably the X1 input, which is the one on the right here, to the chip select on the other socket, which you will be seeing. Oh, we are using the wrong, of course we're using the wrong thing, and we're not using fire. We are using ice again, so we choose ice. Ice USPH, MCU is the F411. So again, build a new image and flash the firmware. So that's good. It's flashing, and yeah, light is red, which is good. And should take just a couple more seconds. There you go. This took quite a bit longer because I think this is more data basically. Probably, I guess. This is done. Now we have to run the second jumper wire. So let's do that. Here's the setup that we need for the multi-ROM image. I've removed all the ROMs that were installed. There is the original ROM, the 325302-1. Here it is. And here is the EPROM replacement for the other ROM, 901229-05. Those are both removed. Instead, we have the ice currently in here, but it will work the same with the fire. The X1 is for the chip select, to select the other chip. You have to make sure that the first ROM image determines where we put this. So the first ROM image was the 325, so it has to go into socket UB3, and we run the jumper wire from X1 to pin 20 of UB4, and you can look that up in the schematics for the 1541. That is the chip select line. And it's a bit of a long cable, so you can run a short jumper wire on the back side of the board, for example, if you want, just solder it there. And you only need one of this at all. You don't need any more original ROMs if you don't have them or if they broke. Let's turn this on. Let's see. It boots up. It's serving data. The power LED is on. The drive LED is off. So we can try and run a command. And let's check. Let's see what this thing here does. And it worked. It tried to do something. It did not find anything because it's broken and there's no disk inside. But the whole thing works just brilliantly fine, stupidly fine, I must say. So there you have it. That is the One ROM. You can replace a ton of different ROMs for 8-bit machines. It even supports the older ROMs that are more complicated for the PAD machines. Those EPROMs, if you want to replace them, are getting really hard to come by. Those are the 27 or 20, whatever, 2508 and 16 and whatever. These here are still relatively common. I think this one here is probably a 128 or 256. You can find these relatively easily. But if you have like 2 broken ROMs, it's already easier to just plop in one of these and run the extra chip select line on the backside. I must say I'm completely in love with this thing, especially the PiPico variant. It's also very nice. You can have it assembled completely, except for the pin headers. Obviously, you need these pin headers and solder them in yourself. Same goes for the jumper connections on the top. I soldered them in as well. But all the other stuff, you can have that done at your PCB manufacturer of your choice. And yeah, I think that is more or less it for today. If you have any other ideas where to use these, there are a lot of ROM sets already available in the One ROM studio. Check out Pier's fabulous YouTube channel. It's definitely worth watching. He does a lot of nice design work and repairs. And yeah, you can also follow me on Mastodon, as I mentioned in the other videos, chaos.social/@root42. And yeah, I hope to see you in the next one, and have a nice evening. Bye!